Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथिरे मु ऑलरेडी प्लस टू सेकेंड इयर सिलेबस कंप्लीट कर सारी एबे मु प्लस थ्री सीबीसीएस फिजिक्स ऑनर्स जीई आ एमएससी फिजिक्स ऑनलाइन क्लासेस रो वीडियोस अपलोड करुच्ची जदि भल लगिला ताले वीडियोस को लाइक कर देबा और चैनल को सब्सक्राइब कर देबो यू कैन शेयर इट विथ योर फ्रेंड्स आल्सो इट्स कंप्लीटली फ्री ऑफ कॉस्ट लेटेस्ट वीडियो नोटिफिकेशन पई बेल आइकन को एठी ऑल रे सेट कर देबो तापरे वीडियोज रो क्लैरिटी बढ़ावा पई गो टू सेटिंग्स क्वालिटी एडवांस उपरे क्लिक करी यू कैन इंक्रीज द रिजोल्यूशन सबू वीडियोज पाई पीडीएफ नोट्स मु पठेबी जोटा एठी ड्रॉप डाउन लिस्ट को क्लिक करी यू कैन गेट द लिंक फ्रॉम द डिस्क्रिप्शन बॉक्स तापरे मोर चैनल नेम को क्लिक कले सबू वीडियोज को मु यूनिट वाइज एच पार सिलेबस सजाई की रखिथिबी व्हिच यू कैन गेट फ्रॉम द प्लेलिस्ट एठी सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें बाइनरी कोलिजन्स विषय रे पढिबा सो बाइनरी माने एठी हम बुझिबा कोलिजन बिटवीन two particles for which we consider actually the elastic collision which is occurring in the free space. So elastic collision mane tome janicho in that case the energy and the momentum both remains conserved mane before collision energy or momentum jaha thibo after collision भी सेया ही रहिबो. Okay, now let us say that the two particles are spinless. Okay, and we consider the particles as molecules here having masses m1 and m2 ताले मोमेंटा आमे इनिशियल स्टेट रो सपोज जदि कहूछु p1 and p2 मन रखो एटा बोल्ड हिची माने एटा वेक्टर नीची ओके तमे लिखला बेल को p1 ऊपरे वेक्टर सिंबल दबो ओके सिमिलरली p2 ऊपरे वेक्टर सिंबल नाउ एनर्जी आमे सिमिलरली नेला e1 and e2 सो दैट एटा काइनेटिक एनर्जी सो एटा हेगला आमे जानिछु काइनेटिक एनर्जी हेगला p स्क्वायर बाय 2m so ei हेगला pi स्क्वायर बाय 2mi so the corresponding quantities in the final state are indicated by the prime symbol okay so momentum ଆଉ energy conservation आमे एबे लिखिबा इनिशियल स्टेट रे नॉन प्राइम फाइनल स्टेट रे जेमति कहूछु आमे प्राइम ओके सिमिलरली एनर्जी को आमे हिसाब रे लिखिबा इनिशियल स्टेट रे नॉन प्राइम फाइनल रे प्राइम सिंबल ओके एठी capital E होची total energy. Now we define the total mass capital M and the reduced mass that is mu like m equal to m1 plus m2 और mu हेगला reduced mass जोटा m1 m2 by m1 plus m2 ताले total momentum आउ relative momentum जदि आमे नबा okay total momentum हला capital P relative momentum small p these two are given by p equal to p1 plus p2 and small p equal to m2 p1 minus m1 p2 divided by m1 plus m2 that is याको जदि तमे टिके सॉल्व करिवो ताले it will come out to be mu into v1 minus v2 एटी v हेगला velocity which is p by m okay so याको एबे जदि सॉल्व करिवा for p1 and p2 we will get the value of p1 and p2 like this okay so it can be easily verified that the total energy now is given by this equation that is 3.16 that is capital P square by 2 capital M plus small p square by 2 mu okay now the condition for momentum energy conservation becomes now simplified okay that is initial momentum equal to final momentum okay similarly at a relative momentum by okay acha that is here the collision merely rotates ए जो collision टा होची जोटा हम starting रे कहला between two spinless molecules it is merely rotating the relative momentum without changing its magnitude देखो एठी ऊपरे ई इक्वेशन रे एटा magnitude relative moment रो समान रहउची ओके किंतु रोटेट करूची सपोज एंगल जदि हमें कहला p dash और p भितरे let it be theta and the azimuthal angle between p dash and p let it be phi okay so these angles completely now specify the kinematics of the collision okay so they are collectively denoted by symbol that is ohm solid angle को एटा आसुची okay and are called the scattering angles okay so we depict the kinematics geometrically as shown in the figure 3.4 you can see here okay figure 3.4 here if the potential which is responsible for the scattering is a central potential mane tome janicho here it will be dependent only upon the magnitude of the distance between the molecules by radius vector by position vector upare he depend kare independent of the angles. Okay, this is called central potential, and here in figure you can see this is the direction of theta, and this arrow mark which is pointing the direction of the azimuthal angle, that is phi. Okay, so ethi ଆମେ ସପୋଜ ଆଠୁ ନେଉଛୁ ସ୍କେଟରିଂ ଯେଉଁଟାକି ହେଉଛି ଇଣ୍ଡିପେଣ୍ଡେଣ୍ଟ ଅଫ୍ ଫାଇ, ଯେଉଁ ପୋଟେନ୍ସିଆଲଟା ଆମେ ନେଲା ଇଣ୍ଡିପେଣ୍ଡେଣ୍ଟ ଅଫ୍ ଫାଇ, ଦ୍ୟାଟ୍ ଇଜ୍ ଦ ଏଜୁମୁଥାଲ ଆଙ୍ଗେଲ। ଓକେ, ତାପରେ ଏଠି ଦେଖ ସିମ୍ବଲ ଦେଇଛି ଗୋଟେ ସ୍ମଲ୍ ଆଇ, ଆଉ ଗୋଟେ ସିମ୍ବଲ ଦେଉଛି ଏଠି ସ୍ମଲ୍ ଏଫ୍। Okay, that means I is for initial direction, F is for final direction without changing the magnitude. Okay, so energy conservation eta rahuchi. So scattering angles are here the angles, that is jemti koili theta and phi, okay, of F relative to I. Okay, individual momenta jodi ame consider kariba ethi second figure ku ebe aso individual momenta of the colliding particles, that is having P1 and P2 may be constructed from capital P, here capital P ethi tole achi ethi, okay, this one capital P, okay, and 2P, 2P mane ethi upare asila, this one, right? So 2P mane 2 times of the relative momentum, that is small p. Okay, so here the points, there are 2 points, that is A and B will coincide at the point O. Okay, they will coincide at the point O, which is the midpoint of the total momentum, that is capital P, if and only if the colliding molecules have equal masses. Okay, mane m1 equal to m2 jodi hela tahale point O re coincide karibo, right? Moving further, the dynamical aspects ebe dekhiba ei jo collision ro. Okay, these are contained in the differential cross section বা differential scattering cross section, এটা প্लस 3 ରେ ବି ତମେ ପଢିଥିବ differential scattering cross section, nuclear physics ରେ ବି ଅଛି ଏଟା, ତା ଛଡ଼ା quantum mechanics ରେ ବି ଅଛି, which is defined experimentally as follows. So for this purpose we consider a beam of particle to incident on particle 1. Okay, गोटे particle 2 अछि जोटा कि particle 1 रे incident hela, and it is regarded as the target particle. Okay, so incident flux को जदि हमें कहला capital I, which is defined as the number of incident particles crossing per unit area per unit time, that is per second from the viewpoint of the target, ताले a incident flux को हमें लिखि परिबा n into magnitude of v1 minus v2, where n is the density of particles in the incident beam, and the differential cross section, that is d sigma by d ohm, is defined by this statement, that is I into d sigma by d ohm into ohm, which is equivalent to the number of incident molecules scattered per second into the solid angle of element, that is d ohm about the direction ohm. Okay, d ohm hochi solid angle ro choto elementary solid angle ta. Okay, a direction ta hela along ohm. Okay, তাহলে এটা হলো differential scattering cross section which has actually the dimension of area. Okay, এটা মনে রাখো, ইয়ার dimension হচ্ছে area র. So the number of molecules scattered into the elementary solid angle, that is d ohm per second, will be equal to the number of molecules in the incident beam crossing an unit area, that is d sigma by d ohm per second. So ଏବେ ଯଦି total cross section ବା total scattering cross section ବାହାର କରିବା, it will be the number of molecules scattered per second regardless of the scattering angle. So sigma total equal to, ଏବେ ଆମେ କ'ଣ କରିବା, ଯେତେ ସବୁ differential scattering cross section ଅଛି ତାକୁ summation କରିବା ବା integrate କରିବା, so এটা ଆସିଗଲା यार integration. Okay, so classical mechanics रे here the differential cross section can be calculated from the intermolecular potential as follows. So आमे कौन करिया, प्रथमे first we transform the coordinate system to the center of mass system in which the total momentum will be 0, and since we are considering only the non-relativistic domain, so this involves a trivial translation of the velocity. Okay, এই figure को पुणी आसीबा. Okay, so it is trivial transformation होची velocity by a constant amount, and for this purpose we only need to follow the trajectory of one of the particle which will move along an orbit. okay so এই जो ଯେକୌଣସି ଗୋଟେ particle जोटा कि along the orbit move କରିବ okay as if it were scattered by a fixed center of force which is at O. okay ଏବେ ପୁଣି वापस ଆମେ figure को ଯିବା okay you can see here the particle approaches the point O with initial relative momentum small p okay and it will recede from point O with final relative momentum p dash and also it is rotated okay so normal distance ebe jodi bahar kariba between the line of approach and O this is our normal distance ଆଉ a distance को कहबा हमें small b which is called as the impact parameter. Now by the conservation of angular momentum it will also the normal distance between the line of recession and O okay and this is indicated in the second figure okay so एटी second figure रे देखो एटा आसीगला फाइनल मोमेंटम रो डायरेक्शन एटा इनिशियल मोमेंटम रो डायरेक्शन दुई भितरे एंगल हला थीटा पुणी एठी phi होची azimuthal angle and here we have taken the elementary solid angle that is d ohm right similarly एठी अछि elementary azimuthal angle similarly एठी होची elementary impact parameter. Now from the figure and from the geometry it is clear that एबे जदि आमे differential scattering cross section को लेखि परिबा I जेमति आमे देखुतिला एटा होची incident flux okay I d sigma by d ohm into d ohm which is I b db into d phi and we can find the relation between the impact parameter b and the scattering angles from the classical orbit equation and thereby we can obtain d sigma by d ohm as a function of scattering angles right so ये जो classical mechanics रो use in order to calculate the differential cross section this was done started by Maxwell okay JC Maxwell okay এটা হচ্ছে ଗୋଟେ old tradition okay classical mechanics as you know it is the old concept okay तापरे यार पुणी modification आसीची जोटा कि modern physics से जहाँ भी हो so predating the quantum mechanics এই ଜିନିଷ calculation ହେଇଛି classical mechanics ରେ and to be correct however we must use the quantum mechanics because quantum mechanics ରେ better result ଆସୁଛି notwithstanding the fact that the between collisions we regard the molecules as classical particles okay so the reason is that when the molecules collide their wave functions necessarily overlap okay माने जो quantum mechanics कहूची जे particle जेतेबेले move करूची there is a wave associated with them and that is the de Broglie wave तमे एटा जानिचो quantum mechanics रे initial state रे तमे पढिचो so wave function रो overlapping actually habo and they see each other as plane wave of definite momenta rather than wave packets of well defined position okay so एटा हला यारो quantum mechanics हिसाब रे concept of collision okay and furthermore formulating the scattering problem quantum mechanically it will make the kinematics and the symmetries of the problem more obvious okay so in case of quantum mechanics the basic quantity in a scattering problem is the transition matrix but T matrix हमें याको कहू whose elements are matrix elements of a certain operator that is TE between the initial and the final state so हमें याको लेखि परिबा এই হিসাবে 1 dash 2 dash মানে এটা হলা after collision and 1 2 hela before collision okay so this operator TE can be written as h dash plus h dash into e minus h0 plus I epsilon ro inverse h dash plus the higher order terms so एठी h0 हे गला unperturbed Hamiltonian आउ h dash हे गला potential आउ एठी epsilon hela actually এটা বহুত ছোট quantity it is approaching towards 0 okay so a collision actually it is a transition from initial state to final state right so for final state in an infinitesimal momentum space element that is d cube p1 dash d cube p2 dash. The rate is actually given by this equation, which is dp12 rho 1 dash 2 dash, which is equal to I d sigma. Okay, further এই जो ट्रांजिशन रेट को आमे into any region of momentum space पाई परिबा केमती जदि এই इक्वेशन को आमे इंटीग्रेट करूछु above over appropriate region, so that आमे differential cross section पाई परिबा by integrating over the recoil momentum, that is P1, which is fixed by the momentum conservation. Okay, and here the magnitude P2 dash, which is determined by the energy conservation. Okay, so integrate kale dekho I d sigma by d ohm ro value ei hisab re ame pai gala. Okay, so here the integrations are actually trivial and it will yield a factor which is representing the density of final states because of the delta function. Okay, delta function, and that enforce the momentum energy conservation. Okay, so for the formal manipulation that we are going to do, however, it is best to leave the integration undone. Okay, integration को पूरा पूरी calculate करी भीतर को जिबार हमरो नहीं. Okay, T matrix को पुणी वापस आसीबा. आमे जानिछु here the T matrix is invariant under spatial rotation and reflection. Okay, and also under time reversal, because all molecular interactions are originating in the electromagnetic interaction. Okay, so we have these invariance properties. Explicitly we can write here that P2 dash P1 dash T P1 P2 এটা তোমার ব্র্যাকেট নোটেশন রে আসিগলা. ওকে, তারপরে এটি RHS রে দেখো গোটে কোয়ান্টিটি আসছি ক্যাপিটাল R. ওকে, capital R মানে here R stands for rotation, and so that RP is the vector which is obtained from the momentum, that is the relative momentum P, after performing a spatial rotation about an axis, obviously with some angle. Okay, and or a reflection with respect to a plane. Okay, so for elastic scattering the density of states are the same in the initial and final one, and thus the invariances of the T matrix directly implies corresponding invariances of the differential cross section. Okay, acha, now if the molecules have spin. Okay, पुणी ये जो ब्रैकेट नोटेशन रे जो इक्वेशन को आमे लिखिला. ओके, दुई प्रकार इक्वेशन आमे लिखुछु. ओके, जेतेबेले एठी आमे r रो वैल्यू लगेला जोटा कि कहूतिला गोटे फैक्टर हिसाब रे ये p को चेंज करूची. Okay, either spatial rotation हो किंबा reflection हो. So the molecules will have spin and it remains valid provided if we interpret the relative momentum p to include the spin coordinate. Okay, जदि spin coordinate को हमें include करिबा ताले एटा valid रहिबो. Okay, and a rotation it actually it rotates both the momentum and the spin, but जदि हमें रिफ्लेक्शन को देखिबा it does not affect the spin. ओके, रोटेशन रे मोमेंटम और स्पिन को ये चेंज करिवो, रिफ्लेक्शन स्पिन को किछि भी चेंज करिवो नहीं. आ थर्ड जिंस जोटा थिला टाइम रिवर्सल, हियर बोथ द मोमेंटम एंड स्पिन विल चेंज इट्स साइन. ओके, अच्छा, देन from equation 3.25 जो ऊपर equation थिला, we can deduce that the inverse collision, which is defined as the collision with the initial and final states, actually interchanged. Okay, hence it will have the same T matrix. Okay, same T matrix yaro rahibo, because here it will have now the same cross section. So again a same T matrix आछी, तेणु आमे देखो प्राइम्ड और अनप्राइम्ड को इंटरचेंज कर देला. ओके, ताले भी किसी भी चेंज हला नहीं. दैट मीन्स TFI इक्वल टू TIF. ओके, सो दिस शो that if we represent the collision by the schematic drawing. Okay, याकू आमे फिगर रे बुझिबा. देखो this figure. Okay, फिगर नंबर A जोटा कि फर्स्ट फिगर. ओके, एठी देखो कोलिजन होउची P1 मोमेंटम रे एठी गुटे पार्टिकल आसिला. ओके, P2 मोमेंटम रे एठी गुटे पार्टिकल आसिला. एटा इनिशियल P1 और P2, तापरे इंसिडेंट हेई कि ए माने P2 डैश P1 डैश एई दिगरे गले. ओके, एई जो ऊपर फिगर को आमे कोरिलेट करि परिबा with just the below figure, that is a dash. ओके एपटे तुमर इनिशियल डायरेक्शन एपटे फाइनल डायरेक्शन आ मन पकाओ ये जो फिगरटा आम देखुचु इट इज वेरी मच आइडेंटिकल विथ द फिगर दैट वी हैव ऑलरेडी सीन ओके देख प्रीवियस फिगर को ए फिगर ओके ये फिगर आसला इे आमर आई इनिशियल एपटे फाइनल डायरेक्शन ओके सो बोथ दीज टू फिगर्स आर आइडेंटिकल ओके सो एटा आसला फर्स्ट फिगर ए सो दैट एबे आमे जदि टी मैट्रिक्स देखिबा in case of this first collision it will be same as the time reversed collision which is represented now by the second figure okay second figure रे कोन करबा हमें टाइम रिवर्सल करबा माने ए जो डायरेक्शन एरो गुडा जो जो पटे अछि हमें यार डायरेक्शन को चेंज करबा ताले सबु जेते रेस्पेक्टिव मोमेंटम आगरे हमें नेगेटिव सिंबल लगे देला ओके अच्छा तापर थर्ड फिगर लक्ष्य करो याकू हमें ए कोऑर्डिनेट सिस्टम को रोटेट करूछु थ्रू 180 डिग्री ताले जो प्राइम्ड क्वांटिटीज प्रथम दुईटा फिगर रे ऊपर थिला ओके एटा एबे तळ को आसीगला हियर कैपिटल आर स्टैंड्स फॉर रोटेशन और नॉन प्राइम्ड क्वांटिटीज ऊपर को पळेला ओके तापरे ए जो रोटेशन आमे एक्चुअली करूछु इट इज बीइंग टेकन along a suitable axis which is along the n direction and it is perpendicular to the total momentum and then reflect with the p dash plane okay p hegala initial relative momentum p dash hegala final relative momentum it is also perpendicular to this n direction okay and finally we coming to the fourth figure jota hochi capital D here this result we can obtain by the inverse of the original collision okay so original collision बा फर्स्ट फिगर रे जहाँ थिला एबे फोर्थ फिगर सहित जदि कंपेयर करबा देखो प्राइम्ड आ अनप्राइम्ड क्वांटिटीज इंटरचेंज हो जाइछि ओके तेणु याकू आमे कहबा इनवर्स ऑफ द ओरिजिनल collision and it has the same t matrix ओके सो ए चारिटा जो फिगर सहित मैच करूछि देखो तले जो रोटेशन बा टाइम रिवर्सल एंड फाइनली द इनवर्स ऑफ द ओरिजिनल collision you can see here फर्स्ट फिगर आउ फोर्थ फिगर रे आई आउ एफ देखो इंटरचेंज हो जाइछि यार डायरेक्शन ओके अच्छा नाउ एबे जदि हमें कहबा if the collision were being treated classically जदि हमें यार क्लासिकल ट्रीटमेंट जदि करथांता ताले the inverse collision could be very different from the original collision and as a concrete example consider the classical collision between suppose a sphere and a wedge okay so ए भलिया गोटे एग्जांपल को आमे जदि फिगर रे बुझिबा यू कैन सी गोटे स्फीयर नउचो एंड दिस इज अ वेज ओके एटा आसिला बिफोर कोलिजन आ एठी आफ्टर कोलिजन स्फीयरटा एपटे मूव करूची वेज भी एपटे मूव करूची माने दुई जण परस्पर आडको मुहामुही मूव करूचंती आफ्टर कोलिजन ओके दे आर गोइंग अवे फ्रॉम ईच अदर ओके सो फ्रॉम दिस फिगर it proves the point that actually it is irrelevant for molecular scattering okay एटा जो आमे फिगर रे कहला एटा तो फिजिकल बॉडी ओके गोटे स्फीयर अछि गोटे वेज अछि एटा फिजिकल बॉडी किंतु मॉलिक्यूलर लेवल को जते बेले आमे पळे आसीबा इट इज क्वाइट irrelevant okay because molecules are not described like wedges or they are not like complete shape of a wedge okay so a non spherically symmetric molecule सबु molecule जे spherical हेबो सेमति भी तो माने नुहे जदि गोटे non spherically symmetric molecule अछि which is the one with non-zero spin and exists in an eigenstate of spin then the angular orientation being conjugate to the angular momentum and it is completely uncertain okay तेणु करी the symmetry between the collision and the inverse collision माने एठी देखो एटा सेकंड फिगर रे देखौची inverse collision माने एबे दुईटा जगह आमे चेंज कर देला ओके वेज टाइप आगरे स्फीयर एठी सेकंड रहउची ताले एबे कोलिजन हेले स्फीयर देखो एपट को जाई कि एपर के ऊपर को चढ़िबो ओके सो स्फीयर डायरेक्शन एपटे आसिला वेज एपटे गला okay but the symmetry between the collision and the inverse collision remains valid when the spin is taken into account जोटा कि quantum mechanics treatment रे पॉसिबल है। ओके क्लासिकल ट्रीटमेंट रे देख ये अलग डायरेक्शन रे मूव करुच्ची एठी अलग डायरेक्शन रे मूव करुच्ची। ओके सो दिस इज ऑल अबाउट द बाइनरी कोलिजन्स।
Thank you.